There are three things that I'm going to cover as part of this presentation. First and foremost thing, wanted to kind of introduce you if you have not been really paying a lot of attention of what's going on from an industry perspective as far as the artificial intelligence and the whole 9 years are concerned. And then we'll talk in retrieval augmented generation. I'll walk you through various views of what RAG means, and then I will leave you kind of a factor for you to kind of take it home with and things which is called agent. I'll quickly touch on that and keep moving into that. So what is AI? So as you can see, this little picture tells 1,000 stories here. The industry is heading this way. So imagine you have a bunch of documents to be processed, bunch of things to be done, and you are kind of you're not sure where to start, how to start, and all that. So for you, figure out for you, and the bunch of agents that robots right next to you, those are called agents or helpers or co-pilots. You can call them. So that's what is the state that the industry as a whole want to take the employees into. So many people been asking me, is AI? Absolutely not.
I'm sorry, your voice is going in and out. I don't know what you're doing with the microphone, but it's somehow I'm missing like half of what you're saying.
All right.
Can
You
you
have to just stay in one place. Don't move
you have to
around.
hit the microphone and hold it right in front of you because this is just
Right, just stay in one place. Don't move around. If you have to, sit down.
This should be working because there's nothing I can do about
it. I could hear that. That I could
Okay.
hear.
Oh, is that
Yeah,
better? All right.
Just stay, just stay right there. Don't move from side to side, just stand in one place.
You know where the
All right.
microphone is?
Okay, sounds good. Let's keep moving. So hopefully you can hear me fine. We got so much to be done, so let's keep moving. All right. So the picture, kind of tells you where the AI industry wants to take if you were to think about an employee and an experience of an employee or an operator or whatever that you can think about, right? So that's what this means. So a bunch of documents thrown all over, and you're trying to figure out and if you look at the other side after AI, so that's where the AI is trying to take you through. All right, so let me move to the next slide. Okay, so you must be wondering why now? So there are a bunch of things in here, and don't be worried about, reading through this whole clutter of things. Yes, ma'am. For sure. It's coming back again. Okay, sounds good. All right. Why now? Okay, and the question that Bob was asking before, are there anyone looking for a job? Is there anybody hiring at this point? So this is the field. The trend kind of shows that the AI jobs are actually, peaking at this point if you compare to the every other jobs. So last month alone, there have been about 9,800 jobs, have been open in the field of AI. So if this doesn't excite you to kind of, start reskilling, upskilling, I'm not sure what else will. So to the right, some of the industry metrics stuff that, just to keep in mind, NVIDIA has launched a chip called Blackwell. So if you haven't heard about it, this is one of the latest and greatest chip. And a couple of tidbits for you from that particular launch. One was that it is a size of your palm. It is a size of your palm. It fits in a size of your palm. It has 208 billion transistors fit into that one chip. So you can imagine where the technology is heading at this point. And the data movement between a GPU to a GPU, it is a cluster of GPUs, right? So it's a GPU to GPU is about 10 terabytes a second. So that's how fast the accelerated computing is kind of advancing at this current point in time. So that is making AI be a well accessible, well advanced, and the whole industry is kind of looking at, okay, how do I get AI? How do I do things faster? Where is my product, a new product, how fast I can launch my new product? What type of things that AI can help you, and so on and so forth. So just wanted to give you that perspective. One of the industry metric that was done by a company named Zscaler, if you haven't heard that name, it's a security firm. There's a lot of softwares that most of the enterprises use that is from Zscaler. One of the metric that they said was 600% increase of AI ML tool usage in the past almost an year time frame, less than an year time frame. So that shows you the advancement and where the industry as a whole that's going. So Jamie Dimon, who is the CEO and chairman of JP Morgan Chase, said AI could be as transformative as electricity or the internet. So we are literally in an era of a next big thing. So and a continuation to the industry exposure, what is that the industry is looking for, looking at these large language models, and what is that they can do, right? So the productivity gains. So this is one of the major application. Co-pilots. So co-pilot is a professor from Wharton University called them LLMs as your intern. So it was so funny how he came up with that analogy. So basically, you can have an intern. So either you hire an intern or get an AI, or think AI as an intern, or an intern can think AI as intern's intern. So that's how to kind of think about it. It can do the job the way that you train it to do the job. Okay. And at the same time, the only difference between it, the actual intern and the AI intern, is that AI intern can lie, but the actual intern cannot lie. It's a HR violation. So that's how he kind of put that analogy into it. So anyway, so the co-pilots is one thing that the industry is adopting. RAG, we're going to quickly touch about that. Co-pilot for every function. If you think about finance as one function, healthcare, billing processing as another function. So they have co-pilots that they are building for pretty much every one of those kind of functions. Agents. So agents, if you're planning for a trip, and Microsoft recently has given a demo about this particular co-pilot, you can literally type in with a prompt and ask the agent to plan everything for you for your particular trip, and you kind of guide the agent through it, and it will do that for you, from finding the credit card of yours and basically surfing through and getting you the best deal possible, and so on and so forth. So that's where the industry is going, and there are multiple things. So this is you must be wondering, who is paying for all of this to happen? There's a ton of companies in Silicon Valley have started recently, and I'm going to show you a slide, and if your jaw doesn't drop, that means you're not paying attention. So Feb 2024 itself, these startup companies have raised about $5.1 billion in the field of AI advancement. And last month, about $6.44 billion. Anyone take a guess how much they have raised this month so far? Anybody?
Damn it. Fuck.
All right, so I'm going to show you this. Over $4 billion have been raised so far. So, it's only the known startups. If you think about the known startups plus the enterprises that are spending, we're talking hundreds of billions of dollars. So I'm going to show you one wow factor here.
Fuck.
Yeah,
God damn it.
say that again. Hello? You probably are not unmute if you're talking. Or you don't like AI. All right, so let's keep going. So think about AI unicorn, April 2024. All these companies combined recently started in Silicon Valley are valuated at around $245 billion. So if you look at where the money is going, where the hiring is happening, and why this field is really advancing, this should really give you an idea. It's not only in the United States, but there are other companies, other countries like Saudi Arabia, spending about $40 billion. South Korea is spending about $7 billion, and so on. All right, so this is a slide that I actually picked it from one of the IBM's presentation. So let's look at the market. What are the people really looking at this AI as, as the next 12 months from now or 24 months from now? Just take the marketing as one field. If you look at marketing as one field, IBM has done a survey, and it kind of showed that about 67% of chief marketing officers in the next 24 months, in the next 12 months, are looking at completely moving into generative AI. And about 86% are looking at basically moving into generative AI in the next 24 months. I don't have another metric presented here, but about 76% of CMOs, chief marketing officers, are talking about if they don't move into generative AI now, they will be losing their jobs or they cannot catch up. So that's how it's kind of a gold rush going on right now, in the technology field as far as this AI is concerned. You might be wondering, why is this happening suddenly? That was the reason why I showed the NVIDIA chip and the other, accelerated computing that's kind of powering these possibilities, as you can see. All right. Okay. So yes. Yes, I'll come to that in a second. Yes. There you go. Yes, Jamie Dimon said it's like an electric and internet era that we're seeing right now. So this is the slide that I just wanted to. It's intentional. You can't read anything from this slide. That was intentional. This is called MAD, as it sounds as mad. It's called the machine learning, artificial intelligence, and data companies landscape. So if you look at the number of companies truly trying to advance and reinvent themselves, this is it. I mean, that kind of gives you a picture. Why now? Move on. All right. So if we drill down that whole bigger picture into a level below and look at healthcare alone, as you can see to the right, you still can't read the slide. That is how many companies are trying to innovate with generative AI and AI as a whole currently, as it is progressing. Right. Okay. Now let's talk about AI. So now we're back to the original topic. I wanted to give you all that kind of a tidbit from what's going on from an industry exposure perspective, and things obviously looking pretty wild as far as the industry is concerned, because everybody's trying to, move as quick as they can and, trying to rediscover themselves in the field of AI. Um, Today is one of the historic days. The reason being Meta, which is Facebook, used to be Facebook, has released a new model called Llama 3. It is outpowering pretty much every other model that exists, and it was just released a few hours ago. So, yeah, exactly, until next week. So, Llama 3 is open source, so which makes the possibilities even higher. That the cost wise, the companies can start adopting. The research wise, you can really truly look at so many different potential ways of really researching and so on and so forth. So let's that's all about the industry hype, right? So we all got it. Why are we really here, and why is this topic such an important thing, and so on and so forth. I live on I live with this moment pretty much every minute of me, because I work for a Silicon Valley company, and we service the startup companies. We help them train their resources. We help them build their products and take them to market and so on and so forth. So we see that firsthand as we we have the exposure there. So let's talk about the ML, DL, and AI. So I kind of intentionally put these into a sequential way: machine learning, deep learning, and artificial intelligence. So there are about, one gentleman has done a fantastic job into summarizing a list of foundational things that as a technologist, if you are a technologist, you need to kind of understand each one of those 43 foundational things. So there are about 43 foundational terms in AI, and which is irrespective of whether you use the large language models, co-pilots, whatever it is, you need to be at the minimum familiarized with those terms and what does that mean and so on and so forth. So I'm going to give you 48 terms. You can't read the slide. Once again, it's intentional. So I'm going to share these slides, so anybody is interested, you can reach out to Dennis and get a copy of this. So let's talk about the artificial intelligence, right? So the technology that makes machines smart and capable of performing tasks like human. Well, will the machines be performing like humans? No. I mean, I need to go to the bathroom. They can't go to the bathroom with me, right? So you know that. So the machines cannot really get to that human part as close to that. So there is a word that we all have to keep in mind while working with AI or anybody having a conversation with you, is called the deterministic and the probabilistic. So these are two different things. The machines are not the AI machines are not deterministic machines. Okay, let's keep that in mind. Probabilistic is what they are all relied on. Why is this probabilistic? It is called the universal approximation. So it gets to the point where it's pretty close to the probability of 99.xyz, right? So that is what kind of makes the artificial intelligence come pretty close to that. If it gets to one, that means we conquered the world. It's not ever going to get to one, because we know we calculate pretty much everything that AI provides is through the probabilities. So keep that in mind. They're not deterministic machines in my view. So these 43 terms are very, very important. So machine learning, let's look at what is a machine learning, right? So the ability of machines to learn and improve from the experience without being explicitly programmed. So let's back up a second here. Many of us, or most of us, have been in the computer science engineering field for a while. What have we learned, right? You have an input, you have an output, and there is an algorithm that runs with it, right? So you need to kind of program it. You need to be, coming up with a smart way, optimized way, XYZ. That's not the machine learning. So the machine learning kind of takes the input, which is data, and produces the output with a representation in between where there is no program. Yes, ma'am. Machine. A machine. Yes. I apologize. My pronunciation, I've been in this country for 28 years. I still can't say the words that you said. Oh, all right. So machine learning, there we go. Machine learning is basically called a representation learning. So what does that mean? You have the input of data and you're expecting certain output of data, right? You're training this machine to learn using this data and put into some kind of a representation that you don't know, I don't know, even machine doesn't know. Okay, so that's how to kind of think about it. And you're guiding the machine to learn based on the data. So you are guiding. So based on how well you train, what data you train with is how smart the machines get into. That's what is called machine learning. If you were to look at it from 100,000 feet level, okay, if we drill down, could mean something different and so on and so forth. So just from an intuition perspective, that's how to kind of think about it as machine learning. Deep learning takes it to the next level, which is, you think about your human brain. Your human brain has what, like, billions and billions of neurons talk to each other. You have your long-term memory, short-term memory, XYZ and all that good stuff. So the neurons kind of connect to each other, and then I'm speaking to you because my neurons are making me speak to you, right? So I'm doing certain things and they're making me do that, right? So that's what the deep learning. So there are, in the world of deep learning, you're trying to get the deeper understanding of certain representation. Let's say I take a picture of Bob, and I'm trying to tell machine, this is Bob, this is Bob. 100 times I take a different sides of the pictures of Bob and feeding the machine to learn this is what Bob is. And I'm trying to teach that through certain things called neural networks, where I'm building the neurons for the machine so it can basically process and represent inside that. So that's what is deep learning from so this is to give you, when I say roots, just going back to the roots of the whole conceptual thing. Artificial intelligence is everything combined together. And if you go a little below, it's the machine learning. If you go a little below, it's the deep learning. Inside that, generative AI is another a little aspect of that whole thing. Generative AI is where we're all heading, and rapidly at this point. Right. I'm gonna do from here. So now that you have learned what artificial intelligence, down to the machine learning, down to the deep learning, and down to the generative AI, let's talk about the large language models. So large language model, I have an analogy for large language model. So at the minimum, if you're walking out of this room with this mindset, it's a genie in a box, not a bottle. I call this genie in a box. Okay. The genie that knows and follows your orders can do the things for you. And we don't know how it is doing the things. Okay, that's what I call it as a large language model. So in essence, basically a language model, like large language model, is an advanced AI system designed to understand, generate, and interact using your language. It's using our language as human language. So you're interacting with this genie, kind of instructing things in our own language, and it is based on whatever it is trained on. It's giving you the output. So that's how to kind of think about it. The structure of an LLM. So you call these models, 7 billion parameter models, 70 billion parameter model, 1 trillion parameter model, blah blah blah, all of that good stuff. When you think about a model, Elon Musk called, I know some may not like Elon Musk, some may like Elon Musk. I'm a fan of Elon Musk because of the innovation he brings in. So if you think about a large language model, he said one thing: large language model is nothing but a .csv file. You must be wondering, what do you mean by .csv file, right? So in an Excel world, it's a comma delimited file. Large language model is nothing but a bunch of matrices with the numbers called weights and biases. That's all it is. So I'm going to show you another slide to kind of walk out of here with an intuition of what that large language model representation is. So this has two components to it. One is the model itself, The second one is a little tiny C program that kind of interacts with you, in the language that you're interacting with. That's it. That's that genie in a box that, we're all so worried about. We're all like want to learn about. We all want to experiment about, and so on, so on, so forth. So the core function of LLMs is the next word prediction. What did I just say? Next word prediction. How am I saying that? Because this genie in the box is making me say a word at a time. I cannot speak 2 words at a time. I can only speak 1 word at a time. So this is another thing to keep in mind. So when you think about an LLM, it can produce a word at a time. Okay. So that's what the large language model is about. Okay. So just leaving you with some good. All right. This is what changed the world. It's called the attention mechanism. So in 2017, basically Google research came up with a paper called Attention is All You Need. That's the paper. So I would encourage, if you are a scientific paper, explorer and reader, I would encourage you all to kind of read that paper. Fascinating thought and so on and so forth. So what is this attention mechanism? So anytime you are saying something, there are specific words that you are stressing or amplifying. Okay, and that's what language is all about, right? So when I say, whatever I'm saying, I'm kind of stressing certain words. That's what his attention is about. In a given sentence, certain words needs a little bit more probability than the other words. That's all attention mechanism is. So that's calculated based on as you can see to the right, that is the actual way of calculating and training the model with the attention scores. So there is something called the self-attention. The word itself will get its own attention. And there's something called the multi-headed attention, which is the word itself in the combination of the other words in that context of it gets a separate score of it. So that is what is called attention mechanism. So why is this so powerful, and how is this changing the whole dimension of things? Before this, this whole transformer architecture, this is called transformer architecture or attention mechanism, came into the play. People have been relying on convolutional neural networks and recurrent neural networks. These are two different, very famous high-end neural network architectures from a deep neural perspective. So one of the things that both of them have its own, good stuff and the bad stuff, not bad stuff, but pros and cons. So what happened was that the RNNs, which are the recurrent neural network, is where most of the innovation was going on and so on and so forth. It had a challenge of, a kind of a loop back mechanism. You have to go back and refeed the network back into it, which is a computationally heavy. And if you think about a machine, you will have to do this in like millions and millions of neurons and, so many layers of neurons. It takes a lot of computing time. So the speed of it was not that great when you look at that. What attention mechanism did, oh, why do I have to come back and retrain this? Why don't I carry something called an attention for each one of these in a quadratic way, which is a simple dot product calculation, and I don't need a lot of computing with that. So that changed the world. So let me back up a second and give you two intuitions to walk away from here. Why is AI so powerful now? Two reasons. One, the attention mechanism I just spoke about, which kind of helped to fast track the computing, right? Two is the accelerated computing itself, which is the NVIDIA chips, and Intel introduced a new thing called Gaudi 3 recently, and so on and so forth. So with your accelerated computing and the attention mechanism kind of reducing, so you're basically both of this, what it did, if you had this much of computing needed, now you only need this much computing. So that kind of changed the world. The innovation's not new. many of the things we're applying now, the math, the kind of technology we're applying behind the scenes, it has been evolving for many years. It's not new, but these two things added to the acceleration that it's taking place. Okay. All right. The RAG aspect of it. So I'm gonna also give you one intuition to walk away with. So this is one thing I mentioned. When you look at the large language model, it's nothing but a .csv file. To your right, is that your right? Yes. Take a look at what you have there. The bunch of matrices where it says weights and the parameter. So x1 is a parameter, w is a weight. So all you're doing is basically you're putting that into all the way to the output, as you can see, a little probability, point something, point something, point something. So you're normalizing it and you're distributing it with the, with the activation for those things. So that's all it is in the inside of the machine. Just to keep, I mean, there's so much of other things exist. I'm trying to oversimplify that just to leave you with some intuitions. So the other thing to keep in mind, I briefly talked about a transformer architecture. So bottom left to you is something called the transformer architecture. So you're feeding the sentence, and you have a bunch of layers, calculating the attention, processing it through, and finally it does something called softmax, and it creates a probability, and that's what is the weights and biases and all that good stuff. So that's how, if you were to peel that onion and look at it inside, that's how the architecture looks like, which we don't care because somebody already figured it out, and you have a large language model to kind of work on it. Unless you are in the research field, there's so many things to look at it. So the other thing to see, it's called the vector representation. So just hold that in your mind of where the man and a woman, and on the other side you have king, and then an arrow pointed down, which is a vector, and that's where you can actually calculate the value and find where that word queen is. That is how the machines work. All you're talking about is a number representation for the text or a language words that we have. Okay? All right. Now let's get into the RAG, right? So what is RAG? So let's first back up a second. So you have this genie in the box, which is a large language model, right? You have all these, wonderful machine learning, deep learning, all that cool stuff that we talked about, right? So somehow I have to be able to use this large language model to benefit my use case. Let's say I'm trying to, write a statement of work or a contract. I have a bunch of contracts that I have done. It takes me like 4 or 5 hours to sit down, copy paste certain classes, and build this contract and give it to my customer, right? How were you used to do that before? Well, you would have a system that's built for you. It'll create a document. It'll probably give you a layout to work with, and so on and so forth. So what changed now? Well, the things that change now, I can basically take all of my old, contracts and all of that, and put some kind of a database for that, which I'm going to say as a vector database. I'll cover that in a little bit, and then I can basically generate this contract based on my old contracts without having to go and pick and choose, and the machine can do it for me. So that's what is called RAG. So the RAG is nothing but retrieval augmented generation. So I'm going to retrieve my content that I have been managing in my, let's say, my organization, or your desktop or whatnot. I'm augmenting this content, and then I'm generating it using this genie in the box. Okay, so now I figured out how I can use this genie in the box, right? So that's what retrieval augmented generation is about. So it's typically used for for making sure that you're not bleeding your data out, when you are actually using these models and things like that. You're trying to keep this proprietary to your own organization and so on and so forth. So let's That's the definition. Before I go to the next thing, I'm going to skip this and touch it a little bit. So, like I was saying, the words, your language is basically translated into bunch of numbers because the computer can only calculate the numbers, put the representations, all that cool stuff. Those are called embeddings. Just keep this in mind. You can read about it later and so on and so forth. So what I'm doing is this. All I'm doing is I'm taking, let's take the scenario of an internet. You have so much information on internet, so much research information, so much Wikipedia information, so much of XYZ information. This genie in a box is basically, they have taken all this information, converted that into a bunch of numbers, that's called embeddings. They have done a semantic nature of this, created this attention mechanism, and of course applied a bunch of other deep learning, whatever, created you this genie in a box. That's all it is. It's nothing but a knowledge base. But for it to get to that point, you need to first understand the embeddings. Embeddings is nothing but every word will be translated into a bunch of numbers. And that's what the machine learning is. So machine learns based on the numbers. Okay. So keep this in mind. And if you think about this whole information, the way I like to give folks the analogy is you take the entire internet of information and convert that into the numbers and relate it somehow, throw it into the sky or a multi-dimensional space, and you take machine's help when you throw it in there to kind of club the information, related information, pockets here, pockets there, pockets here, pockets there. When you're retrieving it, it now knows. That's why I said keep that other picture in mind, a man and a woman, king and a queen. It knows how to go and calculate the like-minded words and generate you the next word like I'm speaking, right? So that's what this intelligence is all about, okay? All right. Got the gist of it, right? So as you can see, there is another word called vector database. Everything that we do in a RAG is all vector database. So these embeddings go into this vector databases. There is so many companies came up with, like our typical database management systems, Oracle, all of that cool stuff. This is all vector databases. There are a lot of companies that came up with these vector database structures that you can use. There is a lot of open source there, commercial there, and so on and so forth. So you take your documents and then convert them into a bunch of these numbers. Use certain representations. There are algorithms available to use that certain representations and put it into a vector database. Second. So in this context, just to give you an example of it, what is the weather like today? Can be phrased in numeral ways, right? Yes. It's outside the LLM. So LLM is something that's it's almost like a frozen weights. You cannot touch it. So if you're augmenting it, so that's where the retrieval augmenting coming into the picture. Yes, yes, I'll show you that as well. It's a great question. So the same question that you have, what is the weather like today? You can ask that same question like, how is the weather today? Is it sunny outside? What am I talking about? I'm talking about the context of weather, right? So these sentences need to stay together somewhere in the context of weather, okay? That's what these these embeddings and vector databases help you with. All right. So again, just to think about this, right? So if you think about the word bank, in the context of you go and you do your transactions, all that good stuff. If you think about the word bank in the context of a river, right? So these are two different things. So you have a bunch of statements talking about, you went to the river bank, or the turtle sitting on the bank, and stuff like that. those are all combined in the context of the bank that is related to the river or something like that, right? But you say, okay, I went with my wife to draw some money from my bank. That's a sentence that's basically in a financial context, in a bank context. So this is how keep in mind, this is how the representation happens within the vector database to kind of separate those out. And all that magic of what I said, the embeddings, vector database, all that take place before this happens. So when the machine's trying to kind of find the similar things, it basically either looking at this circle where it finds out, oh, you're talking about the weather context. Okay, I gotcha. So this is what I'm going to give you. No, you're talking about the context of something else. Let me go find it somewhere else. Okay. So if you represent that with the numbers in a Euclidean space, with so many dimensions around, right, then it can go find where it is and so on and so forth, because it's trying to do that. Okay? All right. So let's look at the RAG from a there are three views I'm going to leave you with. We have 5 minutes. I'm going to leave at least 3-4 minutes for any questions that you may have. Let's look at three views. So one is called the contextual view. The other one is called system view, which I'll touch, and then implementation view, where we're asking about the graph neural network. So if you think about a contextual view, so what happens here is that the user asks a question, and that question of which is basically is a query in the context of query. Oh, can you tell me what is the capital of France? Okay, that's the query. And then what it is doing in a RAG structure perspective, so it's basically trying to find out, is this your internal knowledge I have to go look for, or is it my LLM that I have to go look for? So you're first directing it through your internal knowledge. Okay, that's what is that indexing, retrieval, all that cool stuff is concerned. It's your internal knowledge. Let's keep this in mind. You cannot give up as an enterprise. You cannot give up your data for somebody to take it and train it, because tomorrow your personal information may show up somewhere else. You don't want that risk, right? So that's where RAG comes into the picture. So you're internalizing your retrieval aspect, and then you're actually representing all of your data into your internalized vector databases. And then first you're going to retrieve it from there. Once you retrieve it from there is when you're going to take the help of LLM, which is my knowledge externally, and bring that in and give you whatever the beauty that you want. For example, you want to create a PowerPoint presentation. I'm just giving you an example. These LLMs are capable of sitting down and creating PowerPoint presentations all by themselves without you actually sitting down and creating the slides. But you have some information internally, you want it to kind of take it and do it for you, okay? First, you need to retrieve that information from you. So with the prompt, you're going to say, can you create me a presentation of the last 3 months of my sales, compare that with Microsoft, and tell me how am I doing? Look at that loaded question. What would you do, right? You would basically pull up a lot of documents. You will start analyzing if you were to do it humanly, right? And then you will create a presentation slide by slide by slide. Okay, let me do the comparison. You will throw some Excel sheets, blah, 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 all that good stuff. At the end, you will have a presentation. By the time your boss comes in, asks the question, oh, I'm still working. It's 8 o'clock. I'm still working on it. You don't want to do that. So these LLMs in a RAG structure are capable of doing that for you. Yes. Yes, that. Correct. So I'm showing the contextual view now. So I'm going to go into the system view, and then I'm going to go into the implementation view. You will see that. No. Great question. So this is what a typical, RAG looks like. So about a system perspective, okay, it's almost like you're making the API calls. You get from this database and that database and so on and so forth. So you start the number one, you start with an input. Your system is basically giving the retrieving the relevant information. returning this document. That's the augmentation you're doing right there. I didn't call that as the augmentation. It's returning the documents, and then it's generating the response. So that's the other thing. So it's to kind of think about that. The database is nothing but the vector database in this context. So think about that, more of a vectorization. Vectorization plays with these numbers. So because your data is already converted into the numbers, anything you do, even if you feed a picture, it actually gets converted into the embeddings into a number. Okay, keep that in mind. Right? View. So this is where, as you can see in the middle vector database, I have two things showing up in there. One structure, the other one is actually the database. So that's why I wanted to show you that. So this is the typical implementation view. If you are an IT person kind of looking at how does this work behind the scenes, right? So this is how it works. So there is a concept here. One thing I want to leave you with is called the chunking. So it's a very important topic. So what happens is you take all of your documents, you basically chunk it into certain sizes, okay? Because the machine can give you a better semantic relationship between the statements and between the words. The bit depends on the size of it, depends on the speed of your model, and so on and so forth. So you're basically taking the document, chunking it up, and then you are then creating the embeddings, and then you're putting it into a vector database. In that vector database, now you're trying to index it with the actual chunk to the actual, converted vector numbers. And that's it. That's your internalized knowledge. And then you use any kind of a, a language queries, like, can you tell me this, or show me this, or give me this, all this cool stuff. It can find out based on the words that you're asking. Let's say, oh, how many more holidays left for us in our company? That's your internal information, right? So it can tell you that looking at today is what, okay, how many more days left? How many more holidays left? Where do I get this information? Oh, I'm going to go get this information from here. So it gives you that. Okay. Yes. It's just your text. So if you have a 100-page document, you're basically chunking it to, let's say, 250 words or 250 words, so that it can learn the meaning of that in a better way, and so on and so forth. So there is a strategy that you need to follow for that. There is no hard and fast rule for how many words that I need to take. Yes. Correct. Correct. Well said. And it depends on your, the amount of corpus. Is the word called corpus. Corpus is nothing but all of your knowledge internally, right? Different types of documents and so on. Okay. So different kinds of rags available. It's called naive rag, which is the foundational, what you have seen. There is an advanced rag. What you do in advanced rag is every step in between, you can actually interact with LLMs and make your content the augmented way in much more richer while you get into the final stage of the generation process of it. Okay. Another technique called hypothetical document embedding. So I would let you do of things in here. While implementing this, there is a concept called chain of thought. So someone made this comment during dinner that, how can machines, think, right? So you're basically implementing something called a chain of thought and building a planning around it. So there is a technique that you go through where, it kind of creates the tasks for you when you ask a question. The machine is capable of doing that, and you implement that chain of thought as the implementation approach and give you. I mean, on the left side, the machine made a mistake when somebody asked a question. The cafeteria had 23 apples and they used 20 to make lunch and bought 6 more. how many apples they have, it said 27. But when you implement the chain of thought, as part of chain of thought, you're actually giving the machine an example driven, saying, oh, when I do this, this is what happens. And then when you ask a similar question, it's basically giving you the right answer. So you go through, guiding the machine through the chain of thought. So that's very, very important concept. There's also another concept called tree of thought, react, which is the response and act scenario, and so on and so forth. So there are multiple other things. So I'll stop here. If this doesn't blow your mind, I don't know what else would. The latest model called Grok 1.5 can literally take a flowchart, scribble through your whiteboard, and write the code for you. And they have showed it as the demo. So, and that's it. Any questions?